Um, hi everyone. I'm Shuyao. In this reflection, I'll explore how gene editing helps scientists understand how corals respond to warming waters and how genomics can guide reef conservation. The article I've chosen by Perrin and colleagues from the conversation describes how researchers using CRISPR technology to uncover the genes that give corals their heat tolerance. The study focuses on the HSF1 gene, which acts as a master switch controlling how corals react to heat stress. Using CRISPR, scientists disrupt this gene in coral embryos and observed how their heat tolerance changed. These research links directly to the unique themes of genomics variation and predicting gene function. The Great Barrier Reef hosts more than 600 coral species, yet ocean warming continues to cause widespread bleaching. Understanding which genes protect corals under heat stress is critical to predicting how reefs might survive future climate change. That's why molecular research like this is so valuable. It connects genetics with large-scale environmental resilience. CRISPR works like a precise molecular scissors. It allows scientists to cut and modify DNA to test how specific genes function. In this study, CRISPR components were injected into fertilizer coral eggs to deactivate HSF1. This approach turns genomics into an experimental science, not just sequencing DNA, but actually seeing how genes shape life. The results were striking. When HSF1 was knocked out, coral larvae died rapidly when water temperatures rose to 34 degrees. Normal larvae with HSF1 intact survived much better. This proved that HSF1 is essential for regulating the heat response network, a key discovery for predicting which coral populations are naturally more resilient. This experiment highlights an important genomic pattern. One gene can influence an anti-stress response pathway. By combining gene editing with phenotype observation, researchers can map how genetic variation translates into environmental performance. It's a powerful reminder that genomics isn't abstract. It directly explains how organisms adapt. Connection to unique objects. For me, this article connects science, ethics, and conservation. It illustrates several unit objectives, analyzing genome structure, understanding gene function, and evaluating the social implications of biotechnology. I also learned that gene editing should first expand knowledge, not replace nature. Genomics gives us hope. If we understand how life adapts, we can better protect it.